Okay, so this is a diagram or a picture of the space shuttle used in the space shuttle program. I don't believe that this is the Challenger, but the space shuttle design was the same. Keep in mind that this is a different design from what we looked at when we looked at the Apollo program or the rocket used to launch man into space and land on the moon. So this is a completely different program, completely different design. But I want to go over the three different pieces that was mentioned in the first video so you can see exactly what I was talking about. So this particular piece here, that is the orbiter. And the orbiter carries the payload. Now the payload includes the 7 astronauts that were aboard the Challenger and any experiments they brought, instrumentation, equipment, that would be carried in the orbiter. The orbiter is the only thing that returns to Earth at the end of the mission. And it lands on a runway in Cape Canaveral just like an airplane would. And it kind of has a similar design to an airplane. You have your external tank, and I like to think of the external tank like a huge gas tank. In that external tank, there are different compartments, and one of the compartments contains liquid hydrogen, and one contains liquid oxygen. They're two separate tanks, but they're connected. About 8.5 minutes into the space flight after launch, that jettisons off, meaning it detaches from the orbiter and it falls back towards Earth and burns up in the atmosphere. That is not reused in future missions. We know the orbiter is reused because in the first video I mentioned that it was the 10th mission of the Challenger where the disaster took place. But the external tank detaches, or they call it jettisons off, and it burns up in Earth's atmosphere. You have these 2 solid rocket boosters on the side, and that's to provide initial thrust to launch the shuttle out of Earth's orbit. About 2 minutes into the flight, those are going to jettison off, and those fall into the Atlantic Ocean and are retrieved by the Coast Guard, and those can be used again, which is kind of interesting. Then we have the O-rings, and the O-rings are hard to see here, but they're rubber rings and they're in the shape of an O, so you can see them here and here, and those attach the rocket boosters to the external tank. And what we're going to see in the next diagram, it's just going to take me a moment to get to this one, perfect, is this is where the malfunction happened. So this is kind of an inverted view of it. So less than a second following the liftoff of Challenger, black smoke was seen, which indicated a problem with the O-rings. Now the black smoke wasn't visible from Earth, so people watching the launch on the ground couldn't see the black smoke. There were cameras attached to the orbiter. And the reason there's cameras there is it allows the people in the command post, which is kind of interesting that the flights take place at Cape Canaveral, Florida, but the command center's in Houston, Texas. But there are people whose job it is to watch during launch for any problems. And what they noticed in those cameras was a puff of black smoke, indicating that there was some problem with the O-rings, and they circled where it actually was. About 58 seconds, a small jet of smoke and flame bursts through the side of the booster and quickly grows. So this is from the fuel from the external tank, the big tank, that's starting to leak out as the rocket boosters detach. 73 seconds into launch, the flame burns through the strut, attaching to the solid rocket booster, causing the booster to swivel into the side of the tank, causing what looked like an explosion. So as this was becoming detached because the O-ring was malfunctioning because of the cold temperature, it smashed back into here. And that caused a leak of hydrogen and oxygen, which created that fireball that you're going to see in that CNN video. Now, remember, when we said that took place, the orbiter is going to detach from the external tank and the rocket boosters, and it continues to ascend or move up. So it continues to go up. And at that time, that's when the astronauts are believed to have lost consciousness because of the loss of oxygen and change in cabin pressure. As it started to move back towards Earth, 3 minutes and 58 seconds into the flight, it began its descent, and there's a possibility that the astronauts may have regained consciousness before crashing into the Atlantic Ocean at 200 miles an hour. And that happened about 2 minutes and 45 seconds after the launch. This says 3 minutes 58 seconds, but most places I read says 2 minutes 48, so I'm going to go with that. So this was the first disaster in the Space Shuttle program, again known as the Challenger. After this disaster, there was a 2-year break in the shuttle program for redesign, for problem solving, to make sure something like this didn't happen again. And what we'll learn next Friday is that there was another disaster known as the Space Shuttle Columbia.